How's everybody doing? It's getting late. It's been a long day. I don't know about you, but I've forgotten 3 times what it was I came to talk about. But what I want to do is ask for a hand for Yara. She's been working really hard and doing a great job. Come on, with some energy this time. There we go. So what I'm going to try and do here is, I mean, we've talked about a lot of different topics, and really the subject that I want to focus on is autonomy. AUVSI, not the easiest acronym that rolls off the tongue, but our mantra is all things unmanned, and we're still even working on that. This is a very nomenclature-challenged community when we talk about things that are driverless or highly automated or unmanned and things like that. But from my standpoint, where this is all going is autonomy, and we've been essentially automating things for a very, very long time. And somebody said it earlier, I think best, that when they were referring to electric cars, that electric motors have been around for an awfully long time. But what's happened over time is that technology has started to converge with other technologies and given us some really, really cool stuff. So a lot of people don't remember or know that the original vehicles were almost exclusively electric. Ironically, it was the creation of the electric starter that did in the electric vehicle in the earliest stages, what I call electric vehicle 1.0. And I'm not sure what point, number point we're on at this stage in the game. It's maybe 3.0. Some people might argue 4.0. But this fantastic technology I had the opportunity to promote in my last job. I was working with a group called the Electric Drive Transportation Association, and we were promoting electric vehicles and infrastructure, and I thought, well, we've been talking about a lot of different things. Electric vehicles keeps coming up. To me, the real story about electric vehicles is the technology behind electric vehicles, which is electric drive. And because electric motors have been around for a long time, but there's lots and lots of different ways to apply them. So we've gone from there to, pick it 3.0, 4.0, to, Tesla ludicrous mode. Anybody here really need to go 0 to 60 in 2.3 seconds? Anybody? But it's fun. I'm not quite sure why we need that, but I disagree with whoever it was that said before that people don't drive electric cars for the performance. I think they do, and I've been driving electric for quite a long time. That was all fun, and that happened in a really, really short period of time because of the convergence of technologies. It was really software, faster microprocessor speeds that enable the technologies that we're using now. And electric drive is being used in an awful lot of different ways. In 2015, somebody gave me a call and said, "How do you feel about drones?" And I said, "Well, what kind of drone are we talking about?" And I love things that fly, so I immediately started thinking about this. And this is just an electric vehicle that flies, right? It's got a lot of other interesting technologies. What I didn't see coming, frankly, after I started working with AVSI in 2015, was what happened next. And we'll see if my video runs. Yeah, this is going to fly. This is actually flying. Okay, maybe it's not going to go. We'll try it one more time. There we go. And I'm really glad they saved the music. Now, this guy is a serious aviator because note that hanging strapped to the bottom of his bathtub, which he's flying around using drone technology, is foam rubber, just in case he has a hard landing. You get the idea. Well, maybe it's not going to let me move forward. Okay, people, at the beginning of the dawn of aviation, the mortality rate of pilots was 100%. But we kept doing it anyway. I've been flying for about 27 years. This guy, I think, sort of was a precursor to what happened almost in the blink of an eye, and that is what we're now calling urban air mobility. Electric vertical takeoff and landing, eVTOL, also a very odd acronym. But eVTOL, I think, I wanted to sort of bring these things together because working in the unmanned systems and robotics community, it's almost as diverse as the topics that we've talked about today, although I think I congratulate the organizers. I think they incorporated a lot of different technologies in that I don't necessarily deal with every day. But to me, the convergence of these technologies is going to be the story to pay close attention to. And I'm intentionally moving us now from the ground to the air. And I don't know where he is, our first speaker, who said, you know, why are we messed everything up on the ground, so we're going up in the air. Not necessarily. That's one way to think about things, and we have messed it up on the ground. I couldn't agree more with that statement. And we have a lot of work to do. But I think what I'm noticing about what's happening in the small drone arena is, as we think about what is required in order to get to autonomy, the interesting part to me is that technology, for the campers in the group, technology is not what we call the long pole in the tent. The bigger challenges, and we're somewhere on a range of, you know, a continuum of safety and privacy and security. Ethics is in there too, and I'm glad that we tagged up on that. But when it's all said and done, I think there are fewer things to hit above our heads, and the kinds of things that we can learn by developing a system, what we're calling in the US UTM, or unmanned traffic management, will be extremely valuable to what it is that we need to advance things on the ground. Interestingly, as you know, we kill a lot of people on the ground. We maim even more. And it's shocking to me that we tolerate the numbers that we do. Now, we've all agreed that if we can make cars that don't crash, that would be a good thing, right? No one disagrees with that. We don't tolerate those kinds of numbers in the air. People would never fly if we kill the same number of people in aviation. So we've come up with a higher safety standard in the air. And I'm thankful for that, and you're all thankful for that as members of the flying public. But what we're doing with this technology is we're figuring out, first and foremost, how to integrate it into the existing aviation system with no diminution in safety levels. And then we're going to basically, in parallel fashion, figure out ways of putting people on it as well. This technology, this is actually an older picture now, and I need to update these pictures very, very rapidly. Bell helicopter, Volocopter was mentioned. There are electric, I think some of the best designers in aviation today are working with electric drive and trying to figure this eVTOL thing out. But if you look at their design sheets, and you climb into the cockpit of one of these things, honestly, if you're a pilot, you have no idea what you're going to do. These vehicles are designed almost from the ground up. The pilot's job, as we say, the old joke in aviation is there'll be a pilot and there'll be a German Shepherd. And the pilot's job is to feed the German Shepherd, and the German Shepherd's job is to bite the pilot if he tries to touch anything on the controls. Not a lot of pilots in the group. Everybody always laughs at that one in a pilot group. So this is really, when you get into the, I mean, literally, it's got like two little, I don't know what you would do with this thing other than push the button for the parachute when all else fails. That's what I think is going to end up happening. My point basically is we are trying to figure out, we will figure out how to design a system where vehicles can fly autonomously. Essentially, they're flying a mission from point A to point B, and they will order themselves. That is autonomy. And they will be able to do that safely, and in the integration process, we will figure out a way to do that such that they can give way to manned aircraft in all instances. And of course, for small drones, that's generally folks that are EMS helicopters, things that are, as we say not participating in the aviation system, that might be coming through on an emergency mission and so forth. We're figuring out how to do that. Technology is not the most difficult thing. The most difficult thing, I think, is satisfying the regulators who are responsible to us, the general public, that what it is that we're putting out there is actually safe. It's safe to do something that we've never done in aviation. The entire regulatory system that has given us a very safe aviation system is based on largely two principles. One is one pilot, one aircraft, and the other is see and avoid all other aircraft. Right? And we have air traffic control to keep us, provide separation when we're in clouds. So we're trying to figure out how to integrate into that structure, and ultimately we will evolve to a point where the pilots are essentially not necessary. And if you think that's a crazy idea, it's really not that crazy. These things are basically being set up in such a way that the pilot is going to be there largely for the comfort of the general public. And I think that's, frankly, the larger challenge that we've got in getting from here to a true autonomous circumstance where we've got lots and lots of different technologies being pulled through to support technologies that have been proven, that have essentially we've got great data on, and we can use that data to make it safer down here on the ground where there are a lot more things to hit, where we are integrating with drivers that do crazy things, me too, and essentially, we can learn from one domain in the other domain. I've spent my entire career looking at those enabling technologies like electric drive, but also AI, machine learning, deep learning. All of these kinds of things are coming into our space, and the machines themselves will be able to order themselves over time in a very successful manner. I know that I've been talking to a number of people offline during the lunches and so forth. There's a lot of skepticism out there, not necessarily in this group, but in many areas. And I think that while I wouldn't be pressed for how quickly this is going to happen, it's happening faster than I thought it would have happened. And ultimately, I think the truth is that we are going to get to autonomy where vehicles are ordering themselves in the land domain, in the air domain, and at sea. And I've chosen one of my favorite philosophers to kind of make this point. Arthur Schopenhauer said, I think it was the early 1800s, truth passes through 3 stages. First, it is ridiculed. Second, it is violently opposed. And third, it is accepted as self-evident. Thank you very much.